Hi, for this question, we're going to be exploring another trigonometric principle called the sine rule. All right. So whenever you have a triangle and you have a right angle triangle, okay, that means one of the angle is 90 degrees, then we can straight away use our Pythagoras theorem or our normal tangent, sine, and cosine rules. All right. So just to recall, okay, your Pythagoras theorem says this is CAB, right? So C square equals to A square plus B square. And your normal tangent, sine, cosine rules are tangent theta. So if any of this angle is theta, okay, is opposite over adjacent. Sine theta is opposite over hypotenuse. And cosine theta is adjacent over hypotenuse. Alright, so these are our standard trigonometric rules that we can use to solve right angle triangles quite easily. Alright, but what happens if your triangle is not a right angle triangle? Alright, so this figure here, alright, what you have is you have a triangle. We only know one of the angles, 30 degrees, alright, and we are not given any information that suggests that, for example, angle P is 90. Even though it may look like 90, we cannot assume that it's 90, correct? Okay, but what we do have is we have a side here PQ and a side here PS. We are supposed to find angle PRQ and the length of QR. So this PRQ, which is here, how do we go about doing it? Alright, so since we do not know that it's 90 degrees, a right angle triangle here, we cannot straight away use any of these rules, okay, the standard tangent, sine, and cosine rules, but we can use another sine rule. All right, so let me just quickly recap that rule over here. Now if I have a triangle, okay, and now I'm going to label them. Let's say this is A, this is B, and this is C. All right, and this is angle C, angle A, and angle B. All right, the sine rule says that I can take any side and relate it with the angle opposite. All right, how do you know the side which is opposite the angle? Okay, what you do is you imagine you put your hand to cover the angle. Okay, so when you put your hand to cover the angle, two sides will be touching your hand, one side will not be touching your hand. So that is the opposite side to that angle. All right, so for this small a, this capital A angle is the opposite. So the rule says A over sine A, that means I relate the side and the angle that are opposite each other, is the same as B over sine B, which is the same as which is equal to C over sine C. Alright, so that is your sine rule. Alright, in order to use this sine rule effectively, you can use any pair. So I can take AB, BC, or AC. Alright, any combination. But importantly, when I take a combination, okay, out of the four parameters, so you can see that there are four parameters every time I take a pair. Out of the four parameters, you must know three of them and only one must be unknown. Then only we can solve it. Alright, let me repeat that. Whenever you take a pair, okay, either AB pair or AC or BC, there are four parameters, and out of the four parameters, three must be known and one must be unknown. Then we can solve it. Alright, so coming back to this question here, we can see that for angle PRQ, for this angle, the opposite, so if I were to draw a line here, you can see that the opposite is the side PQ, which is tan. Alright, and since this is the angle that I want to find, PRQ, so this angle, okay, so I'm going to write here sine PRQ over tan must be equals to, alright, so you can write it either way. So you can put the length over the sine, alright, then all your three different pairs will be written the same way, or you can put the sine over the sine of the angle over the length. Alright, then again all three pairs are written the same way. Alright, so in this case I'm writing it the other way, where sine of the angle is on top and the length is below. So sine PRQ over 10 is equals to, I must find another pair, correct? And since this sine PRQ is the unknown, correct, this is what I want to find. For this other pair, I must choose a known set of values, correct? That means a length and an angle that are already known. Alright, so looking back at this triangle, you can see that the other known pair is 6 and 10. Sorry, 6 and 30. Okay, side 6 and angle 30 degrees. So that is what I can use here. So I can say this is equals to sine 30 degrees over 6. Okay, so I hope you can see how we are using this formula here. Alright, you must make sure that you first understand the idea of the side and angle pair. Alright, so the side will pair with the angle opposite each other. Alright, so for this A, this angle A is the opposite. For this angle C, this side C is the opposite. For angle B, side B is the opposite. Alright, so similarly coming back here, for PRQ, this angle 10 is the opposite. For this angle PQR 30 degrees, 6 is the opposite. So these 6 and 30 degrees are a pair, 10 and PRQ are a pair. Alright, so when you use a sine rule, you can either write it as the length or the side over the sine of the angle, then you follow that for all the parts of the equation, or the sine of the angle over the side, then you also follow that for the rest of the equation. Okay, so you can see that with this equation, sine PRQ is what we need to find. So I'm going to just do a cross multiply here. So PRQ is equals to 10 multiplied that is 10 multiplied by sine 30 degrees over 6. Okay, so we're going to key that in our calculator. So I'm just going to do it step by step so that we get it right. So sine 30 degrees is 0.5, so 10 times 0.5 over 6. Okay, so I get 0.8333. So this is sine PRQ. Alright, so sine PRQ is 0.8333. So the angle PRQ is inverse sine of 0.8333. So let me do that. So I'll get 56.44 or 56.4 degrees. Alright, so that is the angle PRQ. So let me put that in. So this angle PRQ here is 56.4 degrees. Alright, now the other thing that we need to find is the length QR. The length QR here. Alright, so you can see that for this length QR, the angle is actually this angle here. Okay, this angle here. So this angle and this side are opposite each other. Correct? Now, if I want to take QR over this angle, currently both are not known. Correct? So in a pair, in the equation here, when I write using the sine rule, like I said, out of the 4 parameters, only one must be unknown, the other 3 must be known. Alright, so if I were to write out the equation now, I will say that QR over sine QPR is equals to, then I can use another known pair. So I can use 10 and 56.4 or 6 and 30. So let me put 6 over sine 30 degrees. Alright, now what you can see is I have two unknowns here, QR and angle QPR. But since this is a right angle, since this is a triangle, alright, I can find this angle here as 180 degrees minus 30 degrees minus 56.4 degrees. Alright, so what I will get here is 180 minus 30 minus 56.4. I will get 93.6 degrees here. Alright, so that angle is now known, so I'll rewrite this equation here. Okay. So QR over sine 93.6 equals to 6 over sine 30. Correct? So in order to find QR, I can cross multiply sine 93.6 over. So QR is equals to sine 93.6 multiplied by 6 over sine 30. Alright, and now what I'm going to do, I'm just going to do it step by step. Okay, I know some of your calculators are very good. Okay, you can key in this entire expression and get the answer immediately, but I'm just going to do it step by step so that we understand. Okay, so sine of 93.6 is 0.998 times 6 over sine of 30 is 0.5. So let me, so 6 divided by 0.5 times 0.998, I'll get 11.98. Okay, so that is the answer for QR over here. Okay, so I hope this question, by solving this question, you have managed to get a good recap of the sine rule, okay, and how it can be applied to solve this question here. All right, thank you. Bye.